Very good morning, students. Welcome to IIT NEET or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, welcome all the class 8 students for today's session. As you all can see in the screen, and you are well aware, my subject is physics. We are in class 8th. Our ongoing chapter, today we are going to start a new chapter, light. And we are entering into we are in the session number 1. After completing the sound chapter in the last class, today we are starting the almost last but one chapter, light today. So before going for the directly to our material, when you recall what we learned in the 6th and 7th classes about the light, so you all know that light is a form of energy because we can do a lot of works with light. Even we cannot imagine our life without light. Hope you all agree. Such a wonderful form of energy which creates sensation of vision. So what happens when the light falls on our retina of eye? It will reflect back and makes the object to visible for us. Suppose when you enter the dark room, we cannot see anything. We cannot see neither bed, nor chair, or nor almirah, nor anything, even fan. But whenever switch on the light makes us to see the object. Such a wonderful form of energy which creates the sensation of vision by falling on retina is called a light. Right? Clear? So there are so many scientists studied about the light and proposed the important theories to explain about the nature of light. So light can travel through even vacuum also. Light can travel through vacuum, not like sound. Sound does not travel, but light can travel through vacuum. So based on the behavior of the material, so whenever you are taken so many materials, whatever available with you, like rubber, plastic, glass, wood, stone, iron, steel, gold, silver, when you keep all in front of you and try to pass the light through them. So based on that, all the materials are classified into transparent materials. The second one is translucent substance, and third one is opaque substance. Opaque, transparent, translucent, and opaque bodies. The substances which allows the light to pass through them 100%. They are called transparent substances. The substances which partially allows, not completely, allows the light to pass through them are called translucent. Whereas the substances which does not allow the light to pass through them, whenever light falls on them, they completely reflect back. Such are called opaque substances like glass, metals, and all comes out of this. These opaque substances will give the very important property of the light called reflection, which we learn in the 6th and 7th class. The first property of light. Reflection. That is returning back of light. Just like you take one rubber ball, hit to the wall. After striking the wall, it will come back. Correct? Same, whenever light passes through the opaque bodies, they returns back after striking the surface. Such property of light is called reflection of light. So it is possible only in case of opaque substances because it does not allow the light to pass through. It reflects the light, absorbs some, reflects the remaining. So we already discussed about the laws of reflection. So whenever light falls on the reflecting surface, the angle of incidence is always equal to angle of reflection. Incident ray, reflected ray and normal lie on same plane. These are the important laws of reflection after doing the activity on reflection. And similarly, we discussed about few important terms related to reflection, like what is incident ray, what is reflected ray, what is point of incident, what is normal ray, what is angle of incident, what is angle of reflection. Angle made by incident ray with normal is called angle of incident. Angle made by reflected ray with normal is called angle of reflection. Both angle of incident is always equal to angle of reflection, which is one of the important law of reflection. So these are the things what we learned in the 6th and 7th classes. But here we are going with the second important property. We are going with the second important property of the light, that is refraction. Right, in this chapter of light, chapter number 7, where we are in the page number 99. Okay, what we are going to discuss? The second important property of the light, refraction. So before going for the start of chapter, I'll give one example. You can do at school also. Take one bowl of water or glass of water, take one plastic scale and place it in the glass of water. Half part of the scale is inside the water. Observe carefully. After going into the water, the scale is observed to be bending. It is observed to be bending. It is not bent, sir. Scale won't bend, but look like it is bent, sir. Why? Because the scale is going from air to water, air medium to water medium. So as light travels from one medium to another medium, it appears to be bending. Such property of bending of light is called, when it travels from one medium to another medium, is called refraction of light. The second one. Reflection is returning back, but you are not returning back, it is passing through. Means the medium should be transparent. For the property of reflection, the medium should be opaque. It should not allow the light. But whereas in case of refraction property, the medium should be transparent medium where light can pass through easily. Such a property of bending of light when it passes from one medium to another medium is called refraction of light. So many ways you can see, as I told, you can take water in glass and insert either scale or pencil into the water and observe the scale or pencil appear to bend. Exactly, they are not bending, whether they bend towards or away. Either sometimes you can bend like this, sometimes bend like this. That depends on the speed. Speed of light in a given medium. That we'll see here. Right. See here. So when light travels in a medium, it propagates in straight line. But what happens when the light moves from one medium to another? There are two mediums are there. The light changes its path while moving from one medium to another. In other words, we can say the light bends at the boundary of the two media. Suppose say this is one medium, right? And this is other medium, air, water. So see, we are incidenting the light. After touching here, what happened? It will bend, bending you can see here. Here you can see bending. On the surface of boundary, suppose I kept a hand like this. From air, light is passing through my hand. Example. So from air, it is coming to my hand. So here the surface is this only, where there is a boundary between the two mediums. At that point, you can see the bending clearly. Such bending of light, the phenomena is called as refraction. Refraction is a phenomena in which light bends as it passes from one medium to another medium. There is a definition of refraction. So many examples, so many applications are there for this property of light after reflection. So the bending of light can take place two possible ways. In the figure 1, the incident ray bends from normal, bends away from normal. Here, see, this is the normal. So this is the light straight line is called normal. Whenever light comes from here, see, from here we are sending arrow mark. So after touching here, what happened is moving away from normal. Whereas here towards normal, means coming close to the normal, away from normal. So it depends on the speed of the light. Okay. The interface of the propagation from the medium 1 to medium 2. The incident ray bends towards the normal at the interference of the ray propagates from 1 into medium 2. So depends on the speed of the medium, speed of light in the particular medium, because you know that light travels with a different speed in the different mediums. So why the given example also given explanation. Why does ray light bend? It has been found that bending of light takes place because of the velocity of light in a different medium. Suppose light may be in air medium, light may be in the water medium, light may be in the solid medium. So medium to medium, the speed of light changes. See here, vacuum or air, speed is 3 into 10 power 8 meter per second. Water speed is 2.24 into 10 power 8 meter per second. Right? Air, you can see 2 into 10 power 8 meter per second. 3 mediums. Right? Glass. So air, water, glass. Gases, liquid and solids. The speed is changing. So because of change of the speed only, the bending of light takes place. If light travels in same medium, it won't bend. It moves in a straight line. That is called rectilinear propagation. But whenever light changes from one medium to another medium, passes from one medium to another medium, there is a bending takes place. Okay. So speed of light in a vacuum also denoted by a c. The speed of light in medium 1, very important point try to understand here. If speed of light is medium 1 is higher as compared to medium 2, then medium 1 is said to be the optically rarer medium. Medium 2 is said to be optically denser medium. Where there is a speed is more, it is called rarer medium. Where speed is less is called denser medium. Whenever light passes from denser medium to rarer medium, the light bends away from normal because less velocity to more velocity. But same time when light comes from rarer medium to denser medium, it moves towards the medium due to less velocity. Very, very important point. Okay. Thus, vacuum is the optically rarer medium. Water is optically rarer than the glass, or glass is optically denser than the compared to water. The speed of light in vacuum is maximum. Is reduced in the other mediums like water or glass. The speed of light reduces in glass. Okay. So different mediums behaves like a different speeds, due to which light bends either towards medium or away from medium. Right? Very, very important about that. So what we learned? Refraction is the property of bending of light when it passes from one medium to another medium. There are two possibilities of bending. The light after entering into the second medium, it may bend towards the normal or away from the normal. So why? Because there are two types of mediums. Where the velocity of light is more is called rarer medium. where the velocity of light is less is called denser medium. If you take air and water, air is a rarer medium compared to denser medium. So whenever light ray incident and passes through the air to water, due to decrease in velocity, light bends towards the normal. When same light passes from water to air, it moves away because velocity is increasing. Okay, so before directly going for the terms, some important terms related to refraction, let me show you one video on the refraction, then we'll move to the next. So these are the terms, very important terms.
Refraction of light. So here are some of the important terms related to refraction of light are as follows. The first one is incident ray. The ray traveling in first medium and actually falling on the surface separating the two media is called as incident ray. In figure, AO is the incident ray. So this is the AO, which is the incident ray. So here we are able to see that this is the line which is separating the two medium. So this is my incident ray. Point of incidence. The point at which this incident ray enters the second medium is simply called as point of incidence. In figure, point O is the point of incidence. So this is O, which is the point of our incidence. Then refracted ray. The ray traveling in the second medium after undergoing refraction is called the refracted ray. And OB is our refracted ray, which is this. So this is OB, which is our refracted ray. Then we have normal.
Incident
It
ray,
is simply a line drawn
ray.
at the point of incidence perpendicular to the surface separating the two media is called as the normal. N1O, N2 is the normal. So let us have a look on the normal. So this is simply our normal.
A perpendicular
This
line
is the normal,
passing through
which
two
is
mediums.
N1O, N2 or N2O, N1. Then we have angle of incidence. The angle subtended by the incident ray from the normal is called as the angle of incidence. Angle AON1 is the angle of incidence, which is angle I. So here is our angle of incidence, which is this. This is my incident ray and this is the normal. And the angle between
here, if you can observe carefully, there are two cases possible. Refraction, two cases are possible. See here. The first one is this. Whenever light coming from one medium to another medium, bending towards the normal. It is coming towards the normal because the speed of the light decreases when entering the second medium. It is coming towards normal. Whereas second case, it is coming and touching, moving away from normal. This angle is more here compared to here. Right? Why? Because there is a change of speed. As speed changes, when light passes from one medium to another medium, we can find the bending. Right?
is angle I, which is the angle of incidence. Then angle of refraction, the angle subtended by the refracted ray from the normal is simply called as angle of refraction, which is N2OB is the angle of refraction R. Here, this is our angle of refraction, which is found between basically refracted ray and the normal. So this is our angle of refraction. Here, what is happening? First of all, when the light travels from optically rarer to optically denser medium. So this is denser medium. We all know water is denser than air. So this is happening that this refracted ray is coming towards the normal. That is
decreasing. So it's coming towards the normal.
But what happens when a light travels from optically rarer?
Glass is more denser
than air. So here the light ray is traveling in the glass, and when it enters the medium, it will move basically away from the normal. It will move basically away from the normal. So this should be the actual path, but it is moving at this side, which is actually away from the normal. So this is our refraction of light. So if we put a glass slab over a newspaper and look from above, the glass slab, words printed in the newspaper appear to be raised and bigger due to refraction of light. Refraction and speed of light. So light travels with a constant speed, which is 3 into 10 raised to power 8 meter per second in vacuum and air. However, when the light passes through other materials, its speed actually decreases. Thus, speed of light is different for different media. For example, speed of light in water is 2.25 into 10 raised to power 8 meter per second, whereas in glass it is 2 into 10 raised to power 8 meter per second. A medium in which light travels faster is called simply optically rarer medium. On the other hand, a medium in which light travels slower is simply called as optically denser medium. So optically rarer and denser media are relative terms. So for example, speed of light in water is less than the speed of light in air. Means we can simply say that water is actually optically denser as compared to air. Similarly, air is optically rarer as compared to water. So this is the relative term. But more than the speed of light in glass. It means that water is optically denser as compared to air, but is optically rarer as compared to glass. Means water is optically rarer as compared to glass because the speed of light in water is more than the speed of light in glass.
Yes.
So again, a ray of light traveling from optically rarer to denser medium, say air to water, bends towards the normal on refraction shown in the figure. It means that when a light ray obliquely passes from an optically rarer medium to an optically denser medium, the angle of refraction is less than the angle of incidence. So angle R has to be less than angle I. So which exactly happens here. So in this case, this is our angle R.
See here,
This
angle
is
of
our
P
angle
is
R.
less than
It
this.
seems to be lesser than angle I. Similarly, in the next case, angle I is smaller because angle I is something like this. So this is our angle I and this is our angle R. So in the second case, angle R is going to be larger than angle I. So when a ray of light traveling from optically denser to optically rarer medium, say glass to air, so bends away from normal on refraction as shown in the figure. It means that when a light ray obliquely passes from an optically denser medium to optically rarer, the angle of refraction is greater than the angle of incidence. Simple.
So
This is
simple
just
cases they are
what we
explained
saw
clearly.
right now. So I hope it is
clear, no? So very wonderfully explained about the what is refraction, what is angle of incident, what is angle of refraction, what is a denser medium, rarer medium, what is the speed of light in denser mediums and rarer mediums, how they behave when the light enter from one medium to another, when it is bends towards the normal, when it is away from the normal. All these are given there, right? Now we'll see about the few terms related to refraction. See here. First one you can see transparent medium. Already I told. To study the refraction, the medium should be transparent. Means it should allow the light to pass through. So the plane surface which refracts the light is called transparent medium. Okay, in the medium XY, say this is the transparent medium. It may be glass, water, or anything. X and Y. Okay. Next, in the point of refraction, the second one. Here only you can see everything diagram. So point of incident means incident ray where it is falling. See the arrow. It is coming this direction. P is the point incident ray. It is falling here. This is called point of incident, where the incident ray is striking the medium. This is point of incident. Normal. A perpendicular drawn. See this dotted line is there, na? This dotted line is called normal. To the refracting surface, when a perpendicular is drawn, that is called as a normal. Incident ray, this is P and something here, PO, something is there. So, incident ray means where the ray which is falling on the surface is called incident ray. So, this is refracted ray. Right? PQ is the incident ray, QR is the refracted ray. Right? Incident, refracted. Clear? Angle of incident. So whenever this is the incident ray, it makes some angle with the normal. This is called angle of incident. The angle made by incident ray with normal. Angle made by reflected ray with normal is called angle of refraction. Angle of refraction. Angle of incident and angle of refraction. Right? These are the important terms. The important terms come across when we are studying about the refraction of light. After knowing about these points, So when you see the law of refraction or loss of refraction, see, observe the diagram carefully. So this is the incident ray coming from air. This is because one medium is air, one medium is water. So incident ray strikes the surface here. So this is the interface between the water and the air. There is a bending is there. It is moving away from the, so towards the normal, because suppose should go like this straight line, but it is bends towards normal. So the first law says that the incident ray, the refracted ray, and normal to the surface at the point of incident all lie on the one plane. All these three are lying on same plane only. First one is incident ray, second one is refracted ray, and third one is normal. See, all three are in the same lane. Second law, for any two given pairs of media is the plural of the medium. Pair, any pair, water, air, one pair, glass, water, second pair, air, glass, any cup pair you take, the ratio of sine angle, as per trigonometry, sine angle of incident is the angle of refraction is constant. That is sine I by sine R. Sine angle of incident means what is the angle of incident? For example, say this is 30 degrees. Right? As it is moving towards normal, it is less than that only. Say 25. So what is the sine 30 by sine 25 is constant as per the law. Observation. The ratio maybe sine I increases or sine R decreases, or sine A decreases, sine R increases. But the ratio always remains same. Is constant, which is denoted by a mu. So mu is equal to sine I by sine R, which is constant, always constant for pair of medium. Number of times if you use water and air as a pair of mediums, we can find that sine I may be increasing, sine R may be decreasing, or both may be increasing, but the ratio is always constant. That is observation made after studying about the refraction. That ratio is called refractive index, denoted by a mu symbol. That is called refractive index. Right. So very important terms derived from the law of reflection. Clear? So in terms of speed also, you can write speed of light in vacuum by speed of light in medium. That is in terms of angle. S sin I by sin R is equal to constant. In terms of speed, if you calculate, you can find the refractive index is given by speed of light in vacuum, because constant value, that is 3 into 10 power 8. Speed of light in a medium, some medium. Suppose coming from air to water. Air is constant for us because 3 into 10 power 8. Water value you can find out by knowing the refractive index. In terms of wavelength also you can find out the refractive index. So in terms of first one is speed. In terms of starting is angle. In terms of wavelength, we can find out the what is the refractive index of pair of mediums. Pair of mediums. Right? So whenever light passes through the slab, there are multiple refraction takes place. Because see here, if you observe here, light is incidenting here, bending, because going from air to glass, bending. So it is straight line because it's the same glass only. But when it enters from the glass to again to air, it is bending away. That is multiple refraction. Multiple refractions also you can see. Right? So, if possible, next class we'll discuss about the remaining part of this chapter. Almost the finishing of this. Right? So, today we'll clearly discuss about the what is the light, an important property of light called refraction of light. So what is refraction? Why is refraction? What way light will bend? What is the reason for bending of light? Why light is bending when passes from one medium to another medium, sometimes towards normal, but sometimes away from normal? What is the speed of light in different mediums like air, water, glass? All these things we learn today. So, when next class, we'll discuss our remaining part of this chapter, right? Till then, so thank you all of you. Have a wonderful day. Thank you.